Okay, YouTube, as we begin our unit on trigonometry, we're going to be dealing a lot with angles, and so it's going to be worth our time to kind of talk about the vocabulary and the basic standard things that we do with angles when we talk about sketching them and interpreting them. So let's go ahead and take a look at this. We say using a protractor, you could use that in a straight edge to draw an angle in the xy coordinate plane according to the description given. And we say one ray should align with the positive x-axis. So one thing I want to kind of mention here right in the first place is this. When we talk about an angle, remember that an angle is where two rays kind of come together. These would be two rays, and they form an angle right there at their vertex. But essentially, we're saying that at each of these angles here, one of the rays has to be on the positive x-axis. And so what we're going to do is we're basically going to sketch these three angles that you see here using a protractor. And I found this nifty little piece of software here. It's a free version, but of a protractor. And so the nice thing with this protractor, let me see if I can kind of manipulate things a little bit better. Ah, no, I cannot. Let's try this again here. If I close out of that maybe, and we'll try this again here. There we go. Well, anyways, if you were to take your protractor, what I want to say is that typically a protractor, the way it looks is you've got this thing that's in this half moon kind of configuration here. Maybe if I hide that. There. You have this thing in this half moon configuration. You see a lot of them kind of have this hollow inner portion, but usually there's like a hole right here that you could like put your pencil tip in, and you have these two lines on the outside. But what we want to kind of understand is that with a regular protractor, we've got this kind of 0 to 180 numbering going either way. But we want to kind of line this line up here with the baseline. And so if I'm going to use this protractor, the first thing I'm going to do is I'm going to line my protractor up with the x-axis here. And so, getting my protractor back out now. If I line this up, you can see here, there we go. With the x and y axis, I see the 90 straight up and down, and then this bottom line is lined up here. We would say 45 degrees. What I would essentially do is go out here, and let's see if I can sketch on here, and I would draw a little notch mark right there. And then let's see if I can hide my ruler again here. Hide that. But basically, using that in a straight edge, we could say, well, then this must be like a 45-degree angle right here. And I want to kind of label this here. We say 45 degrees. You'll notice that I put an arrow starting at the positive x-axis, and you can see that I put it spinning in this direction here. And so we would say to 210, well, how would I do this with a protractor? The thing here is this. You'd have to get your protractor and put it over here, line it up here, line up your baseline with the x-axis. But you'd have to do 180 and put like a little notch mark out here. And of course, we know where 180 is. It's kind of over here on the negative x-axis. But then what you'd have to do is take your protractor and kind of rotate it around so that now it's facing upside down. And so this upside down orientation here, this upside down orientation that you see here, there we go. We would have to go 30 degrees past 180 degrees. So basically when I make this notch mark right here, let me get this hidden again. Basically what you can see is that we went 180 degrees plus another 30. So I'm going to connect that dot right there. We're going to put this arrow around here. We say that this is a 210 degree angle. We'll label that right there. So 300, again, you use your protractor, you'd go 180, but then using your protractor, I suppose you'd have to go another 120 degrees. So one way to look at this is 180. You'd have to go like, another 90 there. This would be like a 270 degree angle using three 90-degree angles here. And then like 30 degrees past that, we could fathom on your protractor, you could see that 120-degree angle would probably terminate right there. So this entire angle right here, this would be our 300-degree angle. So you'll notice that a lot of the time we use these stopping points. And so what I want to kind of, elucidate on here is that these angles that you see all left the positive x-axis and spun in a counterclockwise fashion. Angles that we use as benchmarks quite often are these angles here. We have a 90 degree, 180 degrees, 270 degrees. And we refer to this last one here as either 0 degrees or it could be interpreted as being 360 degrees often. Now we could spin more than 360 degrees, but you notice they kind of stop in the same places that anything between 0 and 360 would. So we're going to use these four angles quite a bit of the time. We refer to these as quadrantal angles. And so let's go ahead and talk about what we mean by an angle in standard position. So standard position, to be very clear, is just meaning this. When we sketch our angles, just like we did on the other page here, you'll notice that this angle in standard position leaves the positive x-axis. And so we say the definition of an angle in standard position says that its initial side is on the positive x-axis. That is to say that its side that it starts at, and you can see that this is where the arrow goes away from here when we rotate, the side that it starts at is on the positive x-axis. So we say an angle is in standard position when its vertex is at the origin and its initial side lies on the positive x-axis. Also, we also have this terminal side, and the terminal side is where it terminates or ending side. That's basically what the terminal side is. We talk a lot about the terminal side of any angle. So you'll notice that we have our 90, 180, 270, and 360 over 0 here. And we refer to this center portion here that's located at the origin, if it's in standard position, as the vertex of the angle. And so we say that the measure of an angle is positive when the rotation on its terminal side is counterclockwise. So an interesting thing about angles is this. When we rotate counterclockwise, we're dealing with a positive angle. So we'll interpret anything that is negative as rotating clockwise or the other direction. So we say the terminal side of an angle can rotate more than 360 degrees. So let's go ahead and take a look at a few angles here that I just want to kind of sketch using those quadrantal angles as benchmarks. And I'm going to write that word down there. We say the quadrant and then the letters AL after that. Quadrantal angles. Quadrantal angles are these angles that occur at the quadrants, and we kind of use those to guide us when we sketch angles. So to sketch a 390 degree angle, what we could say is this is like a 360 degree angle plus another 30 degree angle. And so when we look at that, we would say, well, then I would have to start on the positive x-axis. Here's my initial side if I'm in standard position. And what we're going to do is we're going to rotate around one full time, 360, plus another 30. And so if this is 90 right here, you could say there's 90. 45 would be kind of halfway. 30 is it would have to be kind of like over here. And so we would say that this could relatively be seen as a 390 degree angle here, and we'd say that is how you would sketch an angle over 360 degrees, and it is positive because we rotated counterclockwise. We see a negative angle in this next one here, we say negative 160. So one thing that might be helpful here is to note that we're going to spin clockwise, leaving from the positive x-axis. Now this would be negative 90 right here, and this would be negative 180. So again, we're using these benchmarks. We say negative 160. One way to look at this is like 20 degrees short of negative 180. So 20, a little bit shallower angle than a 30 like we had in that first one there. So I'm going to say it's right around in here, and we could sketch this in. We have to put an arrow here to show which direction we rotate it in, but we say a negative 160 degree rotation. And so this last one here, 690, one thing I want to mention here is this is at least 360. Now if we were to take 690 and take a full rotation off of that 360, we would have left over, it looks like 330 degrees, which would almost be another full rotation. It's almost there, but 30 degrees shy. So to sketch this, we say it's positive. We're going to say leaving the positive x-axis since we're in standard position. We're going to go around once, and then we're going to stop 30 degrees, this is about a 30 degree right here. 30 degrees shy of another full rotation. So this here would be like a 690 degree rotation right there. And so when we explore angles a little bit further here, we're going to talk about what we mean by coterminal angles. Cheers.